Right, question 1. Show that tan theta plus cot theta can be written as sec theta cosec theta. So the first thing I'm going to do is I am going to replace the cot theta with 1 divided by tan theta. Okay, now how can I remember that correctly? Well, with cot or sec or cosec, I always look at the third letter. So for cot, the third letter is T, so it's 1 divided by tan. For sec, the third letter is C, so it's 1 divided by cos. And for cosec, the third letter is S, so it's 1 divided by sine. So that's the best way to remember. Second thing that I need to know that tan theta is sine theta over cos theta. That's one of the most basic identities. And that also means, therefore, that 1 divided by tan will be cos divided by sine. Right? And the reason for that is, right, if I know that tan is sine divided by cos, then if I do the reciprocal of that, I'm going to get 1 divided by sine divided by cos, which is the same thing as cos divided by sine. So now what I want to do is I want to combine these two fractions, and how I'm going to do that, I'm going to give them the same denominator. So the common denominator will be cos sine, so I need to multiply that by sine, and multiply that by sine. And for the second fraction, I need to multiply the bottom by cos, and therefore the top by cos. So what I'm going to end up with here is sine squared theta over cos theta sine theta. And for the second fraction, I'm going to get cos squared theta over cos theta sine theta. And so therefore I can combine these to be sine squared theta plus cos squared theta all over cos theta sine theta. And if I do that, then sine squared plus cos squared we know is 1. So what I'm left with is 1 over cos theta sine theta. And that's the same thing as 1 divided by cos theta times by 1 divided by sine theta. And 1 divided by cos is sec, and 1 divided by sine is cosec. And so therefore we end up with the answer that we were asked to get. Okay, it should be sec cosec. Okay, then question 2, given that y is equal to tan x minus x, find dy dx, and write our answer in terms of tan x. Okay, well, firstly, if we differentiate tan, we get sec squared x. And if we differentiate x, we get negative 1. So I hope that you're comfortable with doing that. That's the basic part. But we need to write our answer in terms of tan x, which means we need to use the identities which are given in the front of the exam. And the identity is going to be that sec squared theta is equal to tan squared theta plus 1. Okay, so what we're going to do is we're going to replace the sec squared x there with tan squared x plus 1. And yet still we've got to subtract 1. So we're going to be left here with tan squared x. Okay, so that's going to be our final answer. Now, hence, right, so the key word here is hence, we want to find the integral of tan squared x dx between 0 and pi by 4. Well, what's the key kind of fact that we've got here? The fact is this, right? If we've got a function, let's call it big F of x, and we differentiate it to get, let's call it little f of x, right? So here what we've done is we've differentiated. Then what that would mean is that if we were to integrate the little f of x, we would get back to the big F, right? So if I differentiate this and get that, it means if I integrate this, I'll get that. Why? Because integration is the reverse of differentiation. So from our last question, we know that if we take tan x minus x, right? So if I've got tan x minus x and I differentiate it, then what I get is tan squared x. Right, so if I differentiate that function, I get tan squared x, which means if I was to integrate tan squared x, then I get back to here. I get tan x minus x. So I can write that out immediately. I can say that I already know that the integral of tan squared x dx will give me tan x minus x. And usually, we'd have to write a constant here, but remember what we've got is we've got a definite integral. We're integrating between 0 and pi by 4. So I'm going to put the boundaries in here, 0 and pi by 4. And I've just got to be careful as I substitute them in. So if I substitute in the upper boundary, pi by 4, I'm going to get tan of pi by 4, which is 1. Remember, your calculator needs to be set to radians. Minus pi by 4. And then I substitute in the lower bound, so tan 0 is 0, and 0 there. So what I should be left with is 1 minus pi by 4. And that should be our answer, and I'm just going to check that with the mark scheme, see if everything's correct. Yep, 1 minus pi by 4 is the correct answer. All right then, question 3, we want to solve the equation 8 to the power of 1 upon x minus 2 times 8 to the power of negative 1 upon x is equal to 1. Now this is a little bit tricky, slightly harder than what we've seen before, but I think the key is to use a substitution. So I'm going to say let u equal 8 to the power of 1 upon x, beg your pardon, 1 upon x. And what that means is that if I've got 8 to the power of negative 1 upon x, that means that that's equal to u to the power of negative 1. Okay, so what I'm going to do here is I'm going to rewrite the equation in terms of u. I'm going to get u minus 2 times by u to the power of negative 1 is equal to 1. And if you think about that, that's the same thing as u minus 2 divided by u is equal to 1, right? Because what does u to the power of negative 1 mean? It means 1 divided by u. So I can multiply everything through by u, which is going to give me u squared minus 2 is equal to u. And so if I rearrange that, I get u squared, sorry about that, u squared minus u minus 2 is equal to 0. And that thing is a quadratic. And hopefully we know how to solve quadratics, right? We will get u minus 2 and u plus 1, beg your pardon, is equal to 0, right? Because I want two numbers that multiply together to give negative 2, and then will add up to give negative 1. And so therefore I've got two solutions. I've either got u is equal to 2 or u is equal to negative 1, right? So I can write u is equal to 2 or u is equal to negative 1. But remember, u is equal to 8 to the power of 1 upon x, right? So this is 8 to the power of 1 upon x is equal to 2, or 8 to the power of negative 1 upon x is equal to negative 1. Well, this one is not valid, okay, because there's no power that can go here that will give me a negative. So this guy's got no solutions. Okay. But what about the other guy? Well, I think it may just be a little bit easier, actually, if we convert the 8 to a 2 to the power of 3. So I'm going to write this as 2 to the power of 3 to the power of 1 upon x is equal to 2 to the power of 1. And therefore, this is going to be 2 to the power of 3 divided by x is equal to 2 to the power of 1. Now, if you're not sure about that, right, what I've just done is I've just used an indices rule. If I've got a to the power of m, and I put it to the power of n, then I multiply the powers, I get a to the power of m times by n, right? That's what I've done there. And so what this means is that 3 divided by x must be equal to 1, and so therefore x must be equal to 3. Okay, so we've got x is equal to 3. Now, I think probably you might have been able to see it directly by looking at this as well, right? Because if I've got 8 to the power of a third, what does that mean? It means the cube root, right, of 8, and the cube root of 8 is 2. So I think you probably could have gone straight from there, skipped straight down to that, but I thought it was good to show you a kind of a more thorough way of doing it, just in case, you know, that's not so clear to you. Okay, then question B of this question. So it is given that a minus root 3 squared is equal to b plus 3 minus b times root 3, where a and b are integers. Find the possible values of a and b. Well, what I'm going to do is I'm going to take the left-hand side and I'm going to expand that, and I'm going to compare it with the right-hand side. Okay, so we've got the left-hand side is equal to a minus root 3 squared. So how am I going to do that? I'm going to get a times a, which is a squared, a times negative root 3, which is negative root 3a, and again, minus root 3a, right? Because I got it twice, yeah? I got a times by negative root 3 and then negative root 3 times by a. And I got negative root 3 times negative root 3, which is going to be positive 3, right? Because negative times negative is positive. Root 3 times root 3 is just 3. So what I'm going to get here, I'm going to get a squared minus 2 root 3a plus 3. So what I'm going to do is I'm going to group together the terms that have got a root 3 and the terms that don't. So I'm going to have a squared plus 3 here and minus 2 root 3a. Okay, so that's the left-hand side. Now what about the right-hand side? On the right-hand side, what I've got is b plus, open bracket, 3 minus b root 3. Okay, so here what I've got is I've got a term which has not got a root 3 and a term which does have a root 3. So we can compare the left and the right-hand side, right? Because this term here without the root 3 should correspond to that term there. And similarly, right, this term here with the root 3, beg your pardon, let me just do that again, should correspond to this term here. So for the bits that are in green, we know that a squared plus 3 will be equal to b. That's one equation. And for the second equation, we've got minus 2a is going to be equal to 3 minus b. Right? Because if we think about it, that's how many root 3's we've got. How many root 3's have we got here? We've got negative 2a. How many root 3's we've got here? We've got 3 minus b. So we have got simultaneous equations, basically. So how can we solve that? Well, we can substitute one equation into the other. So I'm going to rearrange the second a little bit. And that will give me that b is equal to 3 plus 2a. So I'm going to substitute that into the equation on the left. So that will give me a squared plus 3 is equal to 3 plus 2a. And so if I rearrange that, I'm going to get a squared minus 2a is equal to 0, which means that I can factorize to get a minus 2 is equal to 0. So a will be equal to 0, or a is equal to 2. And if a is equal to 0, we can find the value of b, right? We just substitute into 3 plus 2a. So b would be equal to 3 plus 0, which is 3, or b is going to be equal to 3 plus 2 times 2. So 2 times 2 is 4, plus 3 is 7. So those would be the two values. Now let's see if we've got any constraints, right? A and b are integers. Find the possible values of a and b. Okay, well, I think then that's going to be the case that if a is 0, b is 3, and if a is 2, b is going to be 7. Let me just check that against the mark scheme. Yep, that looks correct. Okay, here we are in question 4. The diagram shows the triangle OAC. The point B lies on AC such that A to B to C is equal to P to Q, where P and Q are constants and P is not equal to negative Q. So OA is the vector A, OB is the vector B, and OC is the vector C. We want to show that B can be written in this form here, QA plus PC over Q plus P. In other words, we want to be able to write B in terms of the vectors A and C. Well, really, the key information is this one here, that the ratio A to B, B to C is P to Q. So we're going to indicate that on here. So let's say if that length there is P, okay, then that length here is going to be Q. Now, how is that helpful? Well, because it means we can define the vector A to B in terms of the vector A to C. So let's do that. So AB is going to be equal to P over P plus Q lots of the vector AC. So if we just think about it, right? How far have we got to go along this line of AC? Well, the fraction of AB is going to be P over the total length, which is P plus Q, right? So once we've got that, most other things should sort themselves out for us, because what is the vector AB? The vector AB is OB minus OA, which is the same thing as minus A plus B. Okay, so I can write that here. So I'll write it out in full. OB minus OA. Okay, now if you're really not sure about that, right? If I go from A to B, that's the same thing as doing minus OA and then plus OB, right? So I'm going that way, which is minus A, and that way plus B, is equal to P upon P plus Q times by the vector AC. Well, what's AC? It's going to be OC minus OA. Why is that? Because this vector here from A to C is the same thing as going that way, which is negative A or minus OA plus OC. So we can write here, this is OC minus OA. Now, of course, in the notation that we're given in the question, this is B minus A is equal to P over P plus Q times by C minus A. Okay, so we're almost there. What we want to get is we want to get an expression for B on its own. That means I've got to bring this negative A across to the right. So let me do that. So I've got here B is equal to P times by C minus A all over P plus Q. And I'm going to add the vector A. So now what I want to do is I want to combine these terms here, which means I need to essentially add fractions. So I need to give this thing here the same denominator as P plus Q. So if you think about that, we can imagine that's divided by 1. So what we're going to do now is we're going to times the denominator by P plus Q, which means we've also got to times the numerator by P plus Q. So now if I was to simplify this, what have I got? On the top, I've got P bracket C minus A plus P plus Q times by the vector A, and then all divided through by P plus Q. Okay? So now if I simplify the numerator, what I have is I've got P times the vector C minus P times the vector A plus P times the vector A and plus Q times the vector A, all divided through by P plus Q. And hopefully you can see I've got negative PA and positive PA, so those two terms there cancel off. And so what I'm going to be left with is Q times by the vector A plus P times by the vector C, all divided through by P plus Q. Okay, and that is the answer that we're asked to find. Okay, so here we are in a logarithmic question. Given that log base A of P plus 1 divided by log base PA minus log base A P plus 2 plus log base A5 is equal to log base A12, find the value of P. Okay, now, when you've got a logarithmic question, the first thing you want to ask is, are all the bases the same? Right, now here we've got base A, base A, base A, base A, but this guy here is a base P. Okay, so when we've got a base that's different, the first thing we want to do is we want to change the base so that the bases are all the same. That means we've got to remember the formula for changing the base. So if I have got log base A of x, and I want to change it to be log base b of x, right? So in other words, this thing here remains the same, right? But I'm changing the base from a to b. Then what I need to do is I need to divide by log base b of the old base, right? So I divide by the log of the new base of the old base a, okay? Now, that's something you're going to have to remember, right? It's very important you remember that. And if you want a way to help you, on the right-hand side, the bases must be the same. So on the fraction there, right, the base on the top is b and the base on the bottom is also b. So I think it's a helpful way of remembering. Now then, I want to convert this term, the log base PA. So how can I do that? Well, if I've got log base PA and I want to convert it to log base A, right? So I've got log base A of A, then that means I've got to divide by log base A of the old base, which is P. So in other words, what I'm going to get here is I'm going to get 1 divided by log base A of P. And why is that? Well, because log base A of A is equal to 1, right? And if you're not sure about that, what does this mean? It means what power do I have to give A in order to get A? Well, that power is just equal to 1. Okay, so if I end up with this result, right, then what it also tells us is that 1 divided by log base PA is going to be equal to log base AP, right? So if I just invert this relationship here, I'm going to end up with that. So if I go up to here, what we know about this equation now is that 1 upon log base PA can be replaced with log base AP. So I'm going to write that down. I'm going to have here log base A of P plus 1 plus log base a of p minus log base a of p plus 2 plus log base a5 is equal to log base a12. Okay, now then, you need to know the logarithm rules in order to do this. So what are the logarithm rules? Well, first rule, if I've got log a plus log b, then that will be equal to log of a times b. Okay, and the second rule that we're going to use is this one. If I've got log a minus log b, then that will be equal to log of a divided by b. And the third rule, which we're not going to use in this example, but it's good to know anyway, if I've got log of a to the power of p, then that is equal to p times by log a. Now, in all of these three rules, it's essential to understand that the bases of the logarithms must be the same, right? So I can only apply the rules if the bases are the same. Now then, how are we going to apply that to this particular case? Well, what have we got here? We've got a log plus another log, right? So we can imagine this is like log a plus log b. So we're going to get log of a times b. So we're going to have the log of p plus 1 times by p. Okay, well then what are we going to get? Well, we're going to get that log, but minus another log. So that's going to be rule 2, isn't it, right? If we've got log a minus log b, we're going to have log a divided by b. So why don't we just get along and apply that, and I'll do it nice and slowly step by step. So the first one I'm going to do is I'm going to get log base a of p plus 1 times by p minus log base a of p plus 2 plus log base a of 5 is equal to log base a of 12, right? So what have I done? I've applied rule 1 to the first two logs there. Now I'm going to apply rule 2, right? So I've got log a minus log b. So I'm going to get log a over b. So this is going to become log base a of p plus 1 times by p divided through by p plus 2. Plus log base a5 is equal to log base a12. And then we can apply the first log rule again, because we've got log a plus a log b. So I'm going to get log a times b. So I'm going to get log base a of p plus 1 times by p over p plus 2, right? And then times by 5 is equal to log base a of 12. Well, hang on then. If we look at the left and the right hand side, right, what have we got? We've got log base a of something is equal to log base a of something. Well, that therefore means, doesn't it, that these two terms, the things inside the log, must be the same. They must be equivalent, right? That thing there must be the same as that thing. So we can straight away say, okay, we know that 5 times by p times by p plus 1 all over p plus 2 is going to be equal to 12. Well, this is then just going to be an equation that we've got to resolve, right? So I'm going to multiply both sides by p plus 2. So I get 5p p plus 1 on the left-hand side, 12 bracket p plus 2 on the right-hand side. And so this is going to give us a quadratic. So I think we'll try to expand this. So 5p squared plus 5p is going to be equal to 12p plus 24. So 5p squared minus 7p minus 24 is equal to 0. And I'm hoping that that's going to factorize. So get a 5p there and a p there. And I want two numbers that are going to multiply together to give negative 24. Okay, so we could have, oh, I don't know, 8 and negative 3, or negative 8 and 3. I think it's 8 and negative 3. Let me just try that. Plus 8, negative 3. Let's just see if that works. 5 times by negative 3 is negative 15, plus 8 is negative 7. Okay, so that works. If you weren't sure, you could use the quadratic formula, of course, but it's good to try to be able to do it in our heads. So that's going to give us two solutions. P is equal to negative 8 upon 5, or P is equal to positive 3. Now, before we just finish our answer and we think, yes, we've definitely got it, we need to actually go back and realize that what we've got here is we've got a logarithm. So are both of these answers acceptable? Well, let's just go back up. Right, so here's our logarithmic equation there at the top. So if one of these answers is negative, right, then this particular logarithm is unacceptable, right? Because the argument of the logarithm can't be negative. So if P was negative 8/5, right, then this guy cannot be possible. So therefore, we need to just have P is equal to 3, because that means that all of these logarithms are acceptable. Okay, so we're going to go back down here, and we've got to say not possible, like cross it out, only P is equal to 3. Hope that's helpful. Okay, question 6, which is a circular measure style of question. The diagram shows a shape. A, B, B, D, and D, E are three sides of a rectangle. So that length there, and that length there. So this is a rectangle. OE is the midpoint of BD. Okay, AFE, which is this thing, is an arc of a circle whose center is O. Okay, all right. So it's probably worth indicating that on, right? So the arc there is centered on that. Okay, and AB is equal to root 3, BC is equal to CD is equal to 5, and B to D, so this length here, is equal to 6. Okay, find the exact value of the perimeter of the shape, giving your answer in terms of pi. Okay, this probably looks quite difficult, but if we want to find the perimeter, right, we want to go around the outside of this shape. So what do we need? We need this length here, which we've got, it's root 3. This length here we've got is 5. That length there is 5. That length there is root 3. So we've got everything apart from this arc length here. That's the only thing we don't have, so that's what we need to find. And the arc length is given by S is equal to r theta. That's the formula we need to know, so long as theta is in radians. So what are we going to need? We're going to need to know the radius, which is the same thing as that length there. And we're going to need to know the angle here. Okay, so those are the two things we want to find. So I think what we could do is we can make this into a right angle triangle. So I'm going to make that into a right angle triangle. Okay, and that length there is going to be 3, right? Because it's a half of 6, because O is the midpoint of BD. So we can find the length of OA, can't we? Because we can say that this length here, which I'll call R for radius, R squared will be equal to 3 squared plus root 3 squared. Okay, so 3 squared is 9, root 3 squared is 3. Okay, so if you add those up, we are going to get 12. And so R is equal to the root of 12, which is the root of 4 times 3, which is equal to 2 root 3. So there we go. We've got R is equal to 2 root 3. Now, if we want to find the angle, why don't we try to find this angle here first? So I'll call that, I don't know, phi. How can we find that? Well, we can do tan inverse, can't we, right? So the tan of the angle phi is going to equal to opposite root 3 over adjacent, which is equal to 3. And that's actually the same thing as saying that the tan phi is equal to 1 upon root 3, which is going to be a key angle. Now, why is it a key angle? Well, hopefully you know, if I just go down a little bit, that if we've got 60 degrees, 30 degrees, and 45 degrees, we can get them by using triangles. So this is an equilateral triangle. If it's an equilateral triangle, what it means is that this angle here is 60 degrees or pi by 3. And if I was to cut the triangle in half like that, this angle here would be the bisector, that would be pi by 6. Okay, and this is a right angle. Okay, so then let's make sure, let's state that all of the side lengths of the equilateral triangle are 2, which means that this length here is going to be 1, right, because it's half of the length of the bottom side. And by using Pythagoras, we can get that this is root 3. Okay, and that enables us then to know what is cosine of pi by 3, because it would be adjacent over hypotenuse. The sine of pi by 3 would be opposite over hypotenuse. so root 3 upon 2. And the tangent of pi by 3 would be opposite over adjacent, root 3 upon 1. So this also allows us to see, right, that tan of pi by 6 is equal to the opposite, which is 1, divided by the adjacent, which is root 3. So 1 upon root 3. Now, in the olden days, you had a calculator, but moving forward from 2025, you may not have a calculator. So it's important that you are able to do that, I think. Okay, so essentially what we've discovered is that this angle here, right, this guy is pi by 6, right? That's pi by 6 radians, which means that that angle there is pi by 6 radians. So how can we get this angle, the one that we want, the theta, right? Well, basically then, theta, so if phi is equal to pi by 6, then what we're saying is that theta is going to equal to pi minus pi by 6 and minus another lot of pi by 6, right? Because this angle here is going to be the same as that angle. Okay? So we've got 6 lots of pi by 6 minus 2 lots of pi by 6 is equal to 4 lots of pi by 6, which is equal to 2/3 of pi. Right, so that angle there is 2/3 pi. So now we can find the arc length, right? S is equal to r theta. So our r is 2 root 3. Our theta is 2 pi upon 3. So what we end up here is 4 pi root 3 over 3. That's the arc length. And therefore that means that the perimeter P is equal to 2 lots of root 3 for either sides of the rectangle, plus 2 lots of 5, which is 10 for the triangular bit, plus the arc length there, which is 4 pi root 3 upon 3. And I'm just going to check the mark scheme to see if that is indeed correct. So let me just go do that now. So where are we looking at? 10 plus 2 root 3 plus 4 root 3 upon 3. So 10 plus 2 root 3 plus 4 root 3 upon 3. Hang on, have I got the... yeah, 4 root 3 pi. Sorry, yep, so my answer is correct. Okay, all good. All right, then let's move on to the next one. Find the exact value of the area of the shape, giving your answer in terms of pi. Well, again, what do I need to find the area? I can find the area of this triangle at the bottom. Okay, I can find the area of this triangle here, which is the same as that triangle. And then I can find the area of that sector there. Okay, so let's do each of those in turn. So area, I'll call it, like, describe shapes as shape 1, right? That bottom triangle, this is shape 2, this is shape 3, and the sector is shape 4. So make it nice and clear. So the area of 1 is just a triangle, so it's equal to a half of the base times the height. So the base is 6. Oh, we don't have the height, do we? So we're going to have to find that. Okay, so we can make this into a right angle triangle. Okay, this length here is going to be 3. That length there is going to be 5. This is a right angle. Oh, okay, so it's a 3, 4, 5 triangle. Okay, just using Pythagoras. If you're not sure about that, right, let's call that, instead of calling that 4, let's call it x. X squared plus 3 squared, 9, is equal to 5 squared, 25. So x squared is equal to 16, which means that x is equal to 4. Okay, so we got that. So the total area of this whole big triangle now is a half of the base, which is 6, times by the height, which is 4. So we're going to get, that's going to be 12. Okay, all right then, what about the area of 2, which is equal to the area of 3? That's equal to a half of the base, which is 3, times by the height, which is root 3. So we get 3 root 3 upon 2. And then lastly, the area of the sector, so the area of 4. Well, the formula for the area of a sector is a half r squared theta. So if I just stick that in there, I've got a half. The radius was, what was it? Where was it? 2 root 3? Yeah, it was the square root of 12, wasn't it? So it's a half times by the square root of 12, all squared, times by the angle, and the angle was 2 pi upon 3, I think. Where theta was 2 pi upon 3, yeah. So if I now put that in, I'm going to get a half times by 12 times by 2 pi upon 3. So the 2 is going to cancel, bam, bam. The 3 is going to cancel. That's going to give me 4, which is equal to 4 pi. So then the total area is going to be equal to 12 plus 2 lots of these triangles, so that's plus 3 root 3, plus the area of the sector, which is 4 pi. So I'm going to just check the mark scheme, see if that's right. So 12 plus 3 root 3 plus 4 pi. 12 plus 3 root 3 plus 4 pi is the right answer. Okay. I hope that was helpful, guys. Please like and subscribe if you're finding this useful. Okay, question 7. A curve has equation y is equal to 2x cos x, and the normal to the curve at this point here, pi negative 2 pi, meets the x-axis and the y-axis at the points P and Q. Find the exact area of triangle POQ. Okay, well, we need to break down this problem first, right? The first thing we've got to do is we need to find the normal to the curve. How do we find the normal? Well, the normal is just the equation of a line. And what do we need to find the equation of the line? We need two things. We need a coordinate point and we need the gradient of the line. Now, we've got the coordinate point. That's already done. So now what we need to do is we need to get the gradient of the line. So the gradient of the normal is going to be perpendicular to the tangent. How do we find the gradient of the tangent? Well, we need to differentiate this function. And if we observe this function, what we've got is we've got one function, 2x, multiplied by another function, cos x. So we've got the product of two functions, and so we need to use the product rule, right? So that's the first thing. So our function here is made up of 2x, which we'll call u, and the second function, cos x, which I'm going to call v. And if we remember the product rule is dy dx is equal to v times by du dx plus u times by dv dx, right? So v du plus u dv. So I need to differentiate my u, which will give me 2. And I need to differentiate my v. So cos x differentiates to give negative sine x. And then I just need to stick all of this into the formula for the product rule. So I've got my v here, which is cos x, my u prime, which is 2, plus u, which is 2x, times by my v prime, which is negative sine x. So I'm just going to tidy that up a little bit. I'm going to get 2 cos x minus 2x sine x. Okay, so that's the dy dx. That's going to tell us the gradient of the tangent. Now we want to find the gradient of the tangent at the point where x is equal to pi. So we're going to substitute pi in. So we can write this down when x is equal to pi. Y prime will equal to 2 times by cos pi minus 2 times by pi times by sine of pi. Okay, now what is cos pi? Cos pi is equal to negative 1. So we got 2 times negative 1 minus 2 pi. And what sine of pi is 0. So this is just equal to negative 2. Now, by the way, can I just also mention something? A lot of the students I notice have got a dependence on calculators, right, to know what the values of cos and sine are for the critical angles of like pi by 2, pi by 6, and so on. But then when they come to a question like this, they've forgotten to change their calculator to radians mode. They've got it in degree mode. And so they'll stick in cos pi in degree mode, and they'll get some really, really weird answer, like 0.8972, and they'll write it down. If that happens to you in a question, you need to stop yourself and go, hang on, wait a minute. Does that sound right? I don't think that can be right. Why have I got such a weird number? So you kind of need to build in that mental block that says, wait a minute, if I've got a weird number, have I gone wrong? Okay. Another thing I would recommend, by the way, is if you're doing a differentiation and integration question, which involves sine and cos, right? Before you even start, just set your calculator to radians, okay? Because otherwise you'll forget midway through. Okay, so that aside, what have we got so far? We've got the gradient of the tangent. Now we want to find the gradient of the normal, right? Which means we need to take the negative reciprocal of the tangent, right? Because if two gradients are perpendicular to each other, then their product is equal to negative 1, or it's the same thing as saying one is the negative reciprocal of the other. So if I want to find the gradient of the normal, I need to do negative 1 divided by negative 2, which is going to give me a half, right? So the gradient of the normal is going to be equal to half. Okay, so I've got the gradient now, and I've got the coordinate point, which is pi negative 2 pi. So how can I find the equation of the normal? Well, I can use the formula y minus y1 is equal to m x minus x1. So I'm going to substitute in my values, right? So I've got y minus 2 pi is equal to a half x minus pi. I just want to double check that I've got the coordinates right. Pi negative 2 pi. Yep, that's okay. So this is y plus 2 pi is equal to a half x minus pi. Okay, so now we want to find the x-intercept and the y-intercept, right? So the x-intercept is when y is equal to 0. So that's going to give us 2 pi is equal to a half bracket x minus pi. So that's 4 pi is equal to x minus pi. So x is equal to 5 pi. Okay, so now we know the coordinate of the point P, right? Point P is the x-axis intercept. So P is the coordinate 5 pi, comma 0. And then we want to find the y-intercept, which is when x is equal to 0. So if we substitute in there, we get y plus 2 pi is equal to a half bracket negative pi. So we're going to get here y is equal to minus pi by 2 minus 2 pi, which is minus pi by 2 minus 4 pi by 2, which is equal to negative 5 pi by 2. And so the point Q, I think it is going to be 0, comma, negative 5 pi by 2. Okay, so we've got the x-intercept, which is P. We've got the y-intercept, which is Q. So we want to find the area of the triangle POQ. Well, now if we just think about it, right, what does this actually mean? If we were to draw out a graph of this, right, the graph is going to look something like this. Here's going to be the point P, right? And the point P is going to have x coordinate 5 pi. And here's going to be the point Q, which is going to have x coordinate negative 5 pi upon 2. And so what we've been asked to find is we're being asked to find the area of that triangle, right? POQ, because O is the origin. And how do we find the area of a triangle? Well, we do half of base times height, right? So we do half of this length times by that length. So the area is going to be equal to a half times by 5 pi times by 5 pi upon 2, right? We don't bother with the negative because we're just interested in the length, okay? So that's going to give us 25 pi squared over 4. Okay, so now I'm just going to check my answer against the mark scheme, see if everything is okay. And let's just see that. 25 upon 4 pi squared. That's exactly right. Okay, question 8. A particle moves in a straight line, so its displacement from a fixed point O at time t seconds is x meters, where x is given by this cubic polynomial here. Find the time when the particle changes direction. Well, if we just think about changing direction, right, what does it mean? It means that we were going in the positive direction, and then we change and we go in the negative direction, right? So we have a positive velocity, and then it's a negative velocity, which means that in the middle, we must have crossed through 0. Or alternatively, if we're going in the other direction, right, we had a negative velocity, and then we change direction, and we become a positive velocity, then here, this is going to be 0. Okay, so basically, we're looking for when the velocity is 0. How do we find the velocity? Well, velocity is equal to the rate of change of displacement, right? So velocity is dx dt, right? Because dx dt literally means the rate of change of displacement with respect to time. So if I differentiate here, I should get my velocity. So if I differentiate t cubed, I get 3t squared. T squared differentiates to 2t. Negative t differentiates to give negative 1, and 8 gives 0. So we want to find when v is equal to 0, basically. So we're going to try to solve 0 is equal to 3t squared plus 2t minus 1. So if we factorize that, we're going to get 3t t. So we're going to have two numbers that multiply together to give negative 1. So I think it's going to be positive 1 and negative 1 there, which gives us two values. T is equal to a third, or t is equal to negative 1. And obviously, time cannot be negative. So that is gone. So we know that the particle changes direction when t is equal to a third. Okay, part B. Show that the particle is moving towards the origin when t is equal to 0. Okay, so in this particular question, right, which is quite unusual for the questions in add maths, the initial displacement is not 0. In other words, it doesn't start at the origin. How do we know that? Well, if we take this equation for displacement and we substitute in t is equal to 0, right? So we do t is equal to 0. Then what we're going to get is we're going to get x is equal to 0 cubed plus 0 squared minus 0 plus 8. So x starts at 8. Okay, now what will be the velocity at that time? Well, the velocity will be 3 times 0 squared plus 2 times 0 plus negative 1. So we're going to get negative 1. So let's imagine what that actually looks like, right? So imagine this is our displacement line. Yeah. So we measure x like that. Here's our origin. That's where we start. And here is where the displacement is equal to 8. So what we're kind of saying is, right, that the particle starts here, right? This is where we start at t is equal to 0. We start at displacement of 8. And what's our velocity? Well, our velocity is negative, isn't it? So it's going to the left, right? So v is equal to negative 1. So what does that mean? Well, we are moving towards the origin, isn't it? Right? So we have shown that the particle is moving towards the origin when t is equal to 0. Why? Because when t is equal to 0, we've got a positive displacement, but we've got a negative velocity, which means that we are moving towards the origin. And I think a diagram just really makes that super clear. Okay, part C. So we want to find the total distance traveled by the particle during the first 2 seconds of its motion. Now, we are being asked to find the total distance. We're not being asked to find the total displacement. Why is that important? Well, we know that the particle changes direction. So let's say that we've got a particle here. It kind of moves like that, changes direction, and then does that. Now, its total displacement would be the distance from here to here, right? That would be the displacement, okay? Distance from there to there. But what's the total distance traveled? Well, it would be this distance to here, plus this distance to here, plus this distance to there, right? So every time we change direction, we need to take into account the fact that actually our distance is going to be different to our displacement. So what we need to do is we need to return to our idea of the line, try to understand really what's going on. So here's our line, okay? This is our origin, right? So we start there. This is where displacement is 8, let's say. So we start here at t is equal to 0. And we know that we are traveling in that direction. Okay, now we also know from part A that we change direction when t is equal to a third. So we want to figure out what is the displacement when t is equal to a third. So let's do that. So when t is equal to a third, our displacement x is going to be a third cubed plus a third squared. Okay, so a third cubed plus a third squared minus a third plus 8. So that's going to be 1 upon 27 plus 1 upon 9 minus 1 upon 3 plus 8. Okay, so I'm just going to try to combine all of that. So that's 1 upon 27 plus 3 upon 27 minus 9 upon 27 plus 8. Okay, and so that's going to be 1, 4. 4 minus 9 is negative 5. So we've got 8 minus 5 upon 27. And I suppose I could combine that a little bit, but 5/27 is going to be quite small, isn't it? So we start at 8, and then we kind of move a little distance here to this point. So let's just say that this is where t is equal to a third. So then we know that after that we're going to be moving to the right again, and so we want to figure out where we're going to be when t is equal to 2 seconds. Okay, so when t is equal to 2, we are going to have that x is equal to 2 cubed plus 2 squared minus 2 plus 8. Just make sure I got that right again. Yeah. And so that's going to be 2 cubed is 8, plus 2 squared is 4, minus 2 plus 8. So that's going to give us 8 plus 4 is 12, minus 2 is 10, plus 8 is 18. So we're going to move all the way to 18. So I'm just going to extend my line. Okay. So let's say this is 18 over here. And so this is where we're going to be when t is equal to 2. So this displacement here was our 8 minus 5/27. So now let's try to figure out what is our total distance we travel. We travel from there to there, and then we travel from there all the way to there. Okay, so basically what we want to do is we want to know what this distance is here, and we want to know what this distance is here. Well, this distance is easy, right? That distance is 5/27. So I can just label that and say, okay, that distance there is 5/27. What's this distance here going to be? Well, the distance from 8 to 18 is 10, right? And then the distance from here to here we know is 5/27. So what we're going to get is we're going to get 10 plus 5/27. So I'm going to write down here, okay, so total distance is going to equal to 10 plus 5/27 plus another 5/27. So if I want to combine this, right, this is 270/27 plus 10/27, which is 280/27. And so, I mean, that's going to be roughly 10 point something, isn't it? I don't have a calculator with me, so I'm just going to put it here. Wait, hang on. Okay, so if I just keyed that into a calculator just now that I found on my phone, that gives me 10.370, which I think we better round up to 10.4. Okay, so if I just check that against the mark scheme, okay, the total distance is 10.4 or 10.37. Okay, so that's the answer. So I think the key thing here to remember, right, is that whenever we have got a change of direction, then the total distance is going to be different to the displacement. And I think the best way for you to understand that is just to draw out a quick diagram, right? So you draw a displacement diagram, okay, and you try to indicate on that where you are at particular key points, such as your beginning, where you change direction, and at the end, okay? And then you can usually figure out what's the total distance. All right, question 9. A curve has got equation y is equal to x squared minus 8x plus c, where c is a constant. Want to find the value of c in the following cases. The curve crosses the x-axis at x is equal to 2. Okay, well, if it crosses the x-axis, we know that the y-coordinate is 0, so we've got the coordinate here 2, 0. So we just substitute that into the equation. So y is 0, x is 2, so we're going to get 2 squared minus 8 times by 2, which is 16 plus c. So we've got here 4 minus 16 plus c is equal to 0, which means that c is going to be equal to 12. Okay, so that's the first part there. Second part, find the minimum value of y is 3, or find the value of c when the minimum value of y is 3. I think here it's probably best to think in terms of the completed square form. Okay, so completed square form for a quadratic, in this case, would be x minus a all squared plus b. Okay, and in that particular case, the minimum point is going to be at the coordinate a comma b. Sorry, beg your pardon. A comma b, where a is going to be the x coordinate of that vertex point, and b is going to be the y coordinate of the vertex point, which is also going to correspond to the y coordinate of the minimum value. So if we complete the square, right, then we should be able to find when the minimum value of y is 3. So we've got x squared minus 8x plus c. So y is equal to x squared minus 8x plus c. So if I complete the square, how do I do that? Well, I take the coefficient of the x, which is -8, and I divide it into 2. So I get x minus 4 all squared minus that minus 4 squared plus c. And so that will simplify to give x minus 4 all squared minus 16 plus c, or perhaps I can rewrite that as x minus 4 all squared plus c minus 16. Right, so this thing here, the c minus 16, corresponds to the y coordinate of my minimum point. So if I want that y coordinate to be equal to 3, then what I'm saying is that 3 should be equal to c minus 16, and therefore c will be equal to 19. Okay, so that's how I do the second part. Part B, find the range of values of c for which y is always greater than 0. Well, again, I think if we just use the completed square form, right? So the completed square form was x minus 4 all squared plus c minus 16. Okay, so we basically require that the y value of the minimum point is always greater than 0. So we want that thing always to be greater than 0. So c minus 16 has to be greater than 0, which means that c must be greater than 16. Okay, now, if you're not sure about what I've done there, I'm just going to quickly draw the graph, right? Here's what the quadratic is going to look like. So the y coordinate of the minimum is always going to be at 4, okay? So the minimum will be like whatever there, and the quadratic will look something like this. Okay. Okay, so quadratic will look like that. And the quadratic is going to move up and down, right, depending upon what the value of c is. So we can imagine that we can take that minimum point and we can bring it up and we can bring it down. And basically what we require is that that minimum point is always going to be above the x-axis, which means it needs to be such that the y coordinate of the minimum is always greater than 0. So this value here, c minus 16, is going to be the y coordinate of the minimum. Right, and so we require that thing must be greater than 0, which means that c in turn must be greater than 16. Okay? All right. Okay, question 10. A class contains 7 girls and 8 boys, and a group of 6 is selected from the class. The group must contain at least 3 girls and at least 2 boys. Find the number of different groups that can be selected. Okay, I think the best way to do this is to draw up a table, girls and boys. Okay, so what could I do? Well, I could choose 3 girls, and if I do that, I would need to choose 3 boys to have a group of 6. Or I could choose 4 girls, and then I would have 2 boys. And I could choose 5 girls, but then that means that I would have 1 boy, and I need to have at least 2 boys, right? So that option is out. So there are only 2 ways that I can do this, right? The first way is this way, and the second way is that way. So I've got to ask the question, well, how many ways can I choose 3 girls? Well, there are 7 girls that I can choose from. So that's going to be 7C3. And how many ways can I choose the boys? Well, there are 8 to choose from. So that's 8C3. And the same thing for the second option. How many ways could I choose 4 girls? That would be 7C4. And how many ways could I choose the 2 boys? That would be 8C2. Now, a couple of questions here. Why am I using combinations and not permutations, right? Well, the difference between them is that in combinations, order does not matter, whereas in permutations, order does matter, right? So technically speaking, strictly speaking, permutations is the number of ways to arrange, in this case, let's say 3 items taken from 8, whereas combinations is the number of ways to choose 3 items taken from 8, right? So if we're arranging, we need to use permutations. That means the order matters. If we're not arranging, we're just choosing, we use combinations. So in the context of this question, right, the order in which we choose the students is irrelevant. So we are just going to use combinations, okay? Second thing, why am I multiplying these? Well, because I want 3 girls and 3 boys at the same time, right? So this and this, right? So if I want something and something, then I need to multiply. And then lastly, what am I going to do? I'm going to add up these 2. Why is that? Because I've either got this situation or I've got this situation, and hence I'm going to add up those. Okay, so my final answer is going to be the sum of those. Okay, well, let's assume that we don't have a calculator, right? Because, you know, we've got to prepare for that moving forward. So what's 7C3? That is 7 factorial over 3 factorial, 4 factorial. What's 8C3? That's 8 factorial over 3 factorial 5 factorial. And we're going to add that to 7c4, which is 7 factorial over 4 factorial 3 factorial, times by 8c2, which is 8 factorial over 2 factorial 6 factorial, right? So this is going to be equal to, well, we can simplify this, 7 times 6 times 5 over 3 times 2 times 1, right? So what's happened there is I've cancelled off the 4 factorial from top and bottom. Here we've got the same thing, right? 8 times 7 times 6, cancelling off with the 5 factorial on the bottom. So that leaves me with 3 factorial, which is 3 times 2, plus, well, look, this guy is actually just the same as that guy, right? So I can rewrite that as 7 times 6 times 5 over 3 times 2 times 1. And then 8 factorial over 6 factorial, we're going to get 8 times 7 over 2 factorial, right? Because the 6 factorials cancel off top and bottom. Okay, so let's simplify this some more. So 3 and 2 is 6, so that cancels there. So that just leaves me with 35. And again, 3 times 2 is 6, so that cancels that, right? So that cancels. Same with this, that cancels with that. So 8 times 7 is 56. Okay, and we've got 7 times 5 there, that's 35. And we've got 8 times 7, which is 56 divided by 2, is 28. Okay, so we've got 35 times 56 plus 35 times 28. Again, let's assume we don't have a calculator. I can factorize that. That's 35 and 28. Factorize is to be 2 and 1. So this ends up as 35 times by 28 times by 3. I will times 35 by 3, I think. So 30 times 3 is 90. 5 times 3 is 15. So that's 105 times by 28. And so I could do that as 100 times by 28, which is 2800, plus 5 times by 28. So I times by 10, divide by 2 is 140. And that gives me 2940. Okay, so I think that should be our answer. I'll just check that against the mark scheme. 2940 is the correct answer. Now, I know I'm probably boring you a little bit by like going through all the mental arithmetic and things like this, but 2 reasons. One is I've got students who will say to me, oh, you know, my calculator didn't work in the exam. That's the reason I couldn't do the question. And I just want to point out to you that you can actually do the majority of the question without a calculator. And even the arithmetic, right, if you kind of punch through it a little bit, it's often more doable than you think. So I want to kind of demonstrate to you the techniques of doing that. I think like a lot of students, you've become dependent upon calculators often. And so you need to actually be taught how to do that kind of arithmetic. So that's why I'm showing it to you. The second reason is obviously, you know, some of these exams now you don't have a calculator. So I think you need to stretch that muscle a little bit. So I hope that is helpful. Okay, we're going to go to part B. 5-character code is to be formed from the following characters. We've got these letters here and we've got these numbers here. No character may be used more than once in any code. The characters may be arranged in any order. Find the number of different codes that can be formed using 4 letters and 1 number. Okay, well, I think always want to draw this out, right? So 1, 2, 3, 4, 5, isn't it? We're forming a 5-character code. If we're using 4 letters and 1 number, well, the number could either go here, right? That would be the number. Or it could go here, or it could go here, or it could go here, or it could go here. So what does that mean? That means there are 5 places where I could put the number. And for each of those 5 places, right, there are 3 numbers that I could have chosen. So it's 5 times by 3. So that tells us where the numbers can go, right? There are 5 places where the number could go. And for each of those places, there are 3 options for the number. So then what's left over? Although there are 4 other places that I've got to put in. And those are letters. I've got 6 letters to choose from. I'm arranging them in 4 places. So that's 6p4, right? Now, why am I using permutation? Well, I said in part A, the difference between them is for permutation, order matters, right? It's the number of ways you can arrange 4 items out of 6 instead of the number of ways you can choose, which is for combinations. So in this context, the order of the letters is important, right? Because we're forming a code. So if the order is important, we're going to use permutations, which is what we've got there. Okay, so in the end, what we've got is we've got 5 times 3 times by 6p4. Well, we could write that as 15 times by 6 factorial over 6 minus 4 factorial, which is 2 factorial. And so that is 15 times 6 factorial over 2. And I'll just, this time I will just put that into my calculator, I think. That is 5,400. Okay. Actually, maybe I could have done that as well. Why don't I just do it again? So that's 15 times by 6 times by 5 factorial, right? Divided by 2. So I can then cancel off this 2, right? So divide top and bottom by 2, so that becomes 3. So I end up with 15 times by 3 times by 5 times 4 times 3 times 2 times 1. And so, I don't know, 15 times by 3 is 45. 5 times by 4 is 20. 3 times by 2 is 6, right? No, sorry, 5 times 4 is 20. I don't know. I will do 45 times by 20, so double it, 90, that's 900. Okay, 900 then times by 6 is going to be 5,400, right? Because it's 9 times by 6 is 54. Okay, so again, can be done by using some arithmetic skill. All right, now what's an alternative way of doing this? I think it is helpful to consider an alternative. So I got these 5 things here, and what we could say first is essentially we have to choose one digit. Right, so choose one digit, and we've got to choose 4 letters, and then arrange these 5 characters. Right, so that's what we're doing. So how many ways can I choose one digit? Well, there are 3 digits I could choose, and I choose one of them, so that's 3C1. How many ways can I choose 4 letters from 6? Well, that's 6C4. And you're probably thinking to yourself, well, why am I using combinations here? Well, because at the moment I'm not arranging, right? I'm just selecting what are the digits and letters that are going to go into my code. So I'm going to select them first, and then afterwards, then I'm going to arrange them. Okay, and then how many ways can I arrange these 5 characters? Well, 5p5 or 5 factorial. So I want to choose one digit, which is 3c1, which is like that. And at the same time, I want to choose 4 letters, which is 6c4. And at the same time, I want to arrange them, which is 5 factorial. So if I was to rewrite this right, 3c1 is just 3. 6c4 is 6 factorial over 4 factorial times by 2 factorial. And that's times by 5 factorial. And if I was to simplify all this, that's 3 times by 6 times by 5 over 2 times by 5 factorial. And what is that? Okay, I can write that as 3 times by 3 times by 5 times by 5 factorial, which is 9 times by 5, 45 times by 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is the same thing, isn't it, right? So 45 times by 20 times by 6, which is 900 times by 6, which is 5,400. So there's a different way of doing it, right? And I think it's helpful just to be able to think about 2 different ways. So I give you the option, and you can decide which one makes more sense to you. Okay, so I hope that's helpful. Okay, question 11. The diagram shows the graph of y is equal to f of x, where f is x over x minus 1. And we want to use the diagram to explain why f is a function. And then we want to find f of x, giving our answer in its simplest form. Okay, well, let's try to explain really this idea of one-to-one, one-to-many, and many-to-one mappings, because that's essential really to understanding whether or not something is a function. So we'll start with one-to-one. So here I've got a graph of y equals x plus 2, and this is an example of one-to-one because what does it mean? It means that there is one input, for example, 3, that gives us 1 and only one output, in this case 5, right? So a one-to-one mapping means one input corresponds to one output, okay? Well, let's try the next one. Let's say that we've got a many-to-one mapping. In this case, y is equal to x squared. Why is that many-to-one? Well, because there are many inputs, for example, 3 and negative 3, that give us the same output, 9, right? So if there's more than one input that can give us a particular output, then we say this is a many-to-one mapping, right? Many inputs to one output. And then lastly, we've got a one-to-many mapping, like the graph of x is equal to y squared, where one input, for example 4, could give us many possible outputs, so 2 and -2, right? So we call this a one-to-many mapping because one input corresponds to more than one output. Now, the key thing basically to know is that a one-to-many mapping is not a function. Okay, so a one-to-many mapping is not a function. A function can only be many-to-one or one-to-one. So let's have a quick look at this graph here, right? This is a one-to-one mapping, right? Each possible input has got one and only one output, so this is one-to-one. So it would be an acceptable answer to say that since f is one-to-one. Now, what does the mark scheme say? It says something about, you know, a horizontal line has only got one intersection. So they've got the line, let's say x is equal to k, right? So that's the horizontal line, and that's only got one intersection point here at the graph. Now, essentially what the mark scheme is saying is it's saying that because of this, the function is not a one-to-many, right? Because you've got one input, whatever it is, like x is equal to, I don't know, 3 or something, and it's only got one output, right? If there was more than one intersection, they would mean that there are two possible outputs for that particular value of x, right? So if you can draw a horizontal line through the graph at any point and only have one intersection, it means that the graph cannot be a one-to-many, right? And if it's not a one-to-many, then it is a function. Okay, so that's kind of the rationale there. Okay, find f of x. Well, what does f of x mean? So f of x means we take the function and we substitute it into itself, right? So if our original function is x over x minus 1, which I think it is, right? So f of x is equal to x over x minus 1, then what f of x means that we take this whole function and we substitute it in to wherever we get an x here. So we're going to get x over x minus 1 over x minus 1 minus 1. And so now we can multiply the top and bottom by x minus 1 because we want to kind of get rid of the fractions on the numerator and the denominator. So we'll multiply top and bottom by x minus 1. And if we do that on the numerator, the x minus 1s will cancel, so we'll just be left with x. On the denominator, right, if I multiply this term by x minus 1, I'm going to get x. And if I multiply the negative 1 by x minus 1, I'm just going to get negative x minus 1. Well, then if I simplify this, on the top I've got x, on the bottom I've got x minus x, which is 0, and then minus minus 1, which is 1. So in other words, f of x is just equal to x. Okay, so that is the answer to this one, right? f of x is just equal to x. Okay, well then, using our answer to part 2, state the relationship between the functions f and f inverse. Okay, well, we need to really understand what is an inverse function. Okay, again, I've done this on another video in more detail, but let's try to get it through here. So imagine I've got a function f. Okay, and the function f takes an input x and gives me an output, which we usually call y. Now, what is the job of the inverse function? The inverse function, right, takes in that output y and returns me back to my original input x, right? So in other words, it undoes the job of the first function. So for example, let's say our input to the first function was 2, and we get an output of, I don't know, 7. That means that if I was to take that 7 and put it into the inverse function, I should get back to 2. Right? That is the essential idea. Now then, what have we just learned? We have just learned that if we start with a value of x and we put it into f, and then we take the output of that and stick it into f again, then what we get is we get x. So in other words, right, when we just said that f of x is equal to x, what we're saying is, okay, we've got our value x, we stick it into our function f, right? So that's like this part here. And then we're going to take the output of that, whatever it is, and we're going to stick it into the function f again, right? So we take the output and we stick it into the function f. And what does that give us? Well, it gives us back our original input, x. So in other words, actually what we can say here is this thing has happened. Ooh. We take our output of that, stick it again into the function f, and what does it give us? It takes us back to our original value of x. So therefore, what it means is that f is its own inverse, right? The function f inverts itself. So we can go along here and say, okay, f is its own inverse, right? Because if I stick a value into the function and I get an output, and I take that output and I stick that into the function again, then what I end up with is I end up with the original input, right? And that is, by definition, what an inverse function does. Okay? All right, then. Do I have a next part of the question? Oh, yeah. Oh, sorry. That's part 3. F is equal to F inverse. Part 4, explain how the diagram shows the relationship between F and F inverse. If we just go back to the diagram here, right? One of the properties of an inverse function is it will be a reflection of the original function in the line y is equal to x. So if I was just to draw the line y is equal to x, we would expect the inverse function to be a reflection of the original function in that line. Well, if I take this function here, right, and reflect it in the line y equals x, then I'm just going to get back to the original function, right? Because it's the same thing. So we can say that something like, since f reflected in y equals x gives us f, therefore f is equal to f inverse. Okay, so that's basically the core idea. Okay, all right. Okay, then part B. A function g is defined by g of x is equal to x over x minus 1 for x is greater than 2. Find the range of g. So essentially this is just the same thing as f, but with a different domain. Here the domain is x is greater than 2. So what we can do is we can look at the graph, can't we? So let's take this. Our x values need to be greater than 2. So we can look at the graph there. That's 1, that's 2, isn't it? Right? So that's x is equal to 2. So what we're interested in is we're interested in this part of the graph here. Okay, now hopefully you can see that the range of values here are going to go from the asymptote up to whatever value of y the graph is when x is equal to 2. So we can figure that out. When x is equal to 2, y is going to equal to 2 over 2 minus 1. Is that right? Yeah, which is equal to 2. Okay, so that value there is 2. What's the asymptote? Well, the asymptote is going to be y is equal to 1, right? So we can see that from the graph. Asymptote here is y is equal to 1. So we can say that our values need to go from y is equal to 1 all the way up to y is equal to 2. So our range of the function is everything that's greater than 1. Now, it has to be greater than, not greater than or equal to, because remember, for an asymptote, we can't be equal to it. And it needs to be less than or equal to positive 2. Why is it less than or equal to? Well, because x itself can be equal to 2, which means that y can be equal to 2 as well. Okay? All right, part C here. A function h is defined by h of x is equal to 2x over 3x plus 1 for the largest possible domain. State the domain of h. Well, if we just compare it, right, with this particular graph, essentially, where can we not have a value of x, right? So in other words, the domain goes from negative 10 to positive 10 in this case, and the only value that we can't have is this value here, where we've got a vertical asymptote. Okay, so if we want to have the largest possible domain for this function, essentially we can have all the values of x apart from when we're going to get an asymptote. And when will we get an asymptote, or a vertical asymptote? It's when the denominator is equal to 0. Okay, and the reason for that is we cannot divide by 0. So we set 3x plus 1 is equal to 0, which gives us x is equal to negative a third. So essentially we can say that the domain is x is all of the real numbers, but with the exception that x cannot be equal to negative a third. Okay, and I'll just check the answers so far on that. Yeah, so they just have x is not equal to negative a third. I think, you know, that, I mean, that's all that they want, but it's probably useful as well just to state that it can be everything apart from x is equal to negative a third. Okay, here we've got question 12, which is an arithmetic progression style question. And, you know, it's an unusual one, and it's probably thrown off a lot of students, right? Because it does look very strange. But I want you to see that I think it's probably simpler than we think. So we've got two arithmetic progressions, which each have 100 terms. Their terms are denoted by A1, A2, A3, so on, and B1, B2, B3. It is given that the first term of A is equal to the 100th term of B is equal to 1, and that the 100th term of A is equal to the first term of B, which is equal to 298. Find n such that the nth term of A minus the nth term of B is equal to 45. Okay, well, I think hopefully what we can do is we want to try to define both of these progressions, right? So we want to try to define the progression of A and the progression of B. So what do we need to define any arithmetic progression? We need the first term and we need the common difference. Okay, well, let's focus on progression A. We know that the first term of that is equal to 1. Okay, because that's what we're told there. A1 is equal to 1. So the first term of the progression A is 1. Now, we are also told that the 100th term of the progression A is equal to 298. Now, how can we write the 100th term? Well, we can say it is A plus 99D. So A plus 99D will equal to 298. And we know that A is equal to 1. So we can therefore say that 99D is equal to 298 minus 1, which is 297. And so D is going to equal to 297 divided by 99, which is equal to 3. So the progression A, right, has got first term 1 and common difference 3. So it's progression 1, 4, 7, 10, 13, and so on and so on and so on. Okay, and I think we can do the same thing for B, right? B, we're told that the first term is equal to 298. Okay, so first term is equal to 298. So the first term of that, A, is equal to 298. Now, I know I'm being a little bit naughty because I'm using A to mean two different things for two different progressions. So I hope you'll forgive me for that. Probably on the exam, it's better if you use different letters, but I just want to do that in this case, right? So I'm using A to refer to the first term of this particular progression. And we're also told that the 100th term of the B progression is equal to 1. So how can we write the 100th term of the progression? Well, A plus 99 D is equal to 1. And the first term we've seen is 298. So 298 plus 99D is equal to 1. And so therefore 99D is equal to negative 297. So D is equal to negative 3. Okay, so we've got a slightly different progression here, right? But one that kind of matches up with B, with A, because B is going to be 298. That's a very odd way of writing that. 298, and we're going to be subtracting 3 each time, right? So we're going to get 295, and then 292, and so on and so forth, right? So those are the two progressions. Okay, so we want to find n such that the nth term of A minus the nth term of B is equal to 45. Well, how can we get the nth term of the function A? Right, so we'll write it here, right? So an minus bn is equal to 45. Okay, so the nth term of the function A is going to be 1 plus n minus 1 times by 3, right? Because That's the nth term of that progression, first term plus n minus 1 lots of the common difference. We can do the same thing with the progression for b, right? It's going to be the first term, which is 298, plus n minus 1 times by the common difference, which in this case is negative 3. And that is going to equal 45. Okay, so let's expand all this, I think. So we're going to get 1 plus 3 lots of n minus 1 minus 298. So we got minus 3. So right, it's plus 3. So plus 3 lots of n minus 1 is equal to 45. Okay, just give me 1 second. All right, sorry about that. So we can combine these, right? So I will move the 298 to the right-hand side and the 1 as well. And we've got 3 lots of n minus 1 plus 3 lots of n minus 1, which is 6 lots of n minus 1. So we've got 298 plus 45 minus 1. Okay. All right. So 6 lots of n minus 1. Okay, I don't have a calculator with me, so I'm just going to try to figure that out. So let's say 300 plus 45 is 345, minus 1, 344, minus another 2, 342. Okay, and that should divide by 6. Yeah, how's that going to divide by 6? Let's divide it through by 3 first. Sorry, guys, I don't have my calculator. So that's 114, I think. Yeah. So n minus 1 is going to equal to 57. So n should be equal to 58. Okay, I'm just going to check the mark scheme, see if that is indeed correct. Yeah, n is equal to 58. Okay, so I think a little bit of patience there. It is a difficult question. It is an unusual question, but if you push through, it should be okay. Okay, part B, we want to find the smallest value of m such that am is greater than 2 lots of bm. Okay, I think we just do this the same way. So the mth term of the a progression will be 1 plus m minus 1 times by the common difference, which was 3, greater than 2 lots of, okay, so bm, the first term was 298, plus m minus 1 lots of negative 3. Okay, so let's just expand all this out, I think. So 1 plus 3m minus 3 is greater than, okay, so we've got 2 times by 298. So let's do 2 times by 300 is 600 minus 4, 596. 2 times by negative 3 is negative 6. We're going to get negative 6m plus 6. I'm going to move the negative 6m to the left. So I add 6m to both sides. That gives me 9m. And I'm going to have 596 plus 6, which is 602. And on this side, right, we've got 1 minus 3 is minus 2. So I've got to add 2 to both sides. Okay, so 9m is 604. So I need to divide this by 9. Okay, I don't have a calculator, so I'm gonna do it long division way. So 604 divided by 9. Okay, how many 9s go into 60? Is 6, isn't it? And that will give me 54. That gives me a remainder of 64. Then how many 9s go into 64? It's 7, because you get 63. So we've got a remainder of 1 there. Okay, so I think that m is going to be greater than 67 and 1/9. Well, we can't have a fractional number of terms, right? We can only have integer number of terms. Therefore, m must be greater than or equal to 68, right? So the smallest value of m will be 68. And I'll just check the answer. Yeah, that is correct. Okay, if you're finding these videos helpful, guys, please like, subscribe, share them with your friends, and good luck with your exams.